Yo people, wagwan, welcome back to Ron's Tech Hub. So in this one I'm going to be speaking about just a few components I have for the Raspberry Pi Pico. Now these are things I'm going to be using in the future on the Raspberry Pi Pico. Time frame, I have no idea to be fair, but I am going to be getting around to it at some point because I'll be doing it for Unit 6, Engineering BTech Level 3, and for Unit 19 in IT, which is Internet of Things. Alright, so at the back, let me start from the back, going from left to right I guess. This is a Raspberry Pi 2. This is the older Raspberry Pi version 2. I've got heat sinks on here. What did I use this for? I think I used this for my university project. I probably made a home security system for the first one, I believe, and the second one I did some other thing. So this is what the Raspberry Pi looks like, the original Raspberry Pi. This Raspberry Pi is just a mini computer, a mini PC, and as you can see, I've got HDMI, I've got 3.5 mil headphone jack, and I think this also did RCA video. I have Ethernet port, I have 4 USB ports, and back here I've got the same GPIO pins as a typical Raspberry Pi 4. Now, if I can see that properly, that's the DSI. That's a display port, and that one is CSI, that's a camera port. So this was a marker USB to power it. So this is what the Raspberry Pi looks like. This is the original design of the Raspberry Pi, and I think this one had the Wi-Fi chip built on as well, if I'm not mistaken. Next, I have the Arduino Mega. Now this device, I really like this device. One of the reasons I liked it so much is that it had so many pins. If I'm not mistaken, this had 64 pins, which was really good for a project, because what could happen is that you could have so many sensors attached. Now I'm going to bring in the Arduino Uno as well. So this is the Arduino Uno on my right and the Arduino Mega on my left. More or less the same type of device. The one on the left, as you can see, has a lot more pins. So that means I can connect more devices. But again, they're connected in the same way. They use a USB port. They also were able to be powered from an external power supply. But these are the older devices. Now I'm going to be speaking about the Raspberry Pi Pico itself. So I've got one attached to a breadboard here. Let me try and give you a close-up as I can. So that's a marker USB port there. I wish it was USB-C, but it is what it is. This one was a Pico H. Pico H simply means it came with the headers already soldered on, so I didn't have to do any soldering. I am in the process of trying to source a Pico W with Wi-Fi. They're only £10 on eBay, so they're not expensive at all, but I just didn't want to spend any more money seeing as I have so many components already. So this is what the Raspberry Pi Pico looks like again. Let me put this down. I have an LCD screen. This is a 16 by 2 LCD screen, I believe. That's mainly what these cheaper ones come in. Honestly, this is so cheap. You can get this for less than £1 on eBay in some cases. And I have one other component which I want to use with this. That one there. This is an I2C adapter. So if I pull this off and show you, this one here, this uses, if it's not 8, is it 8? I don't even remember how many pins this uses, but however many it uses, I'm going to connect all of these pins to this device here, right? They have the same amount of pins. And what's going to happen, that's going to convert it into only 4 pins. So the I2C adapter for this device here is going to make me use only 4 pins. So 4 of these are going to go to the Raspberry Pi Pico. So that's the purpose of this device here. So let me put these down, put these back to the back there. Here I have a RFID reader, and here I have the RFID tag. Now how this works, typically, when you guys are at uni or college, you tap your ID card onto a surface, the gate opens, the door unlocks. This is the type of thing that they have on the inside. These are one type of tag, and here's another one. This is typically what people will see and maybe recognize a lot quicker. So the plan for this is simply to have some door opening logic, right? I might not have an actual motor connected to anything to open anything or some device, but I'm going to program the logic. So maybe when you tap it, if you are allowed to enter the system, or if your card number is allowed, you'll be able to see like a green LED go on. And if you're not allowed, I'll put a red LED on, something like that. So that's that. This is a very important device. This is a PIR, passive infrared sensor. I have never understood why they call it PIR, because PIR is supposed to be obviously an abbreviation of passive infrared sensor. So it should technically be PIS, but for obvious reasons, I don't think they chose that word. But this picks up radiation, so maybe that's why they call it PIR, actually, passive infrared radiation sensor. So this is a motion sensor. For anyone here, if you've gone into the toilets at any building, school, college, university, you would see these tiny things sticking out of a relay somewhere. What this does is going to pick up the radiation in that room, or pick up movement, let's say, in that room. Once it picks up movement, it triggers the system to do something else. So this is what it actually looks like. There are smaller versions of this, and again, this is, I would say, £1 on eBay. So if you are looking into getting into electronics, Raspberry Pi Pico, £5–10, that's that thing over there. Each of these components you can grab on eBay for less than £5 guaranteed. I found on eBay these two devices, so the 16:2 display and the I2C adapter. I found them for less than £3, which is absolutely amazing, right? What's this again? A sonar sensor. So it pulses and receives. And I think it should be labeled here. Yeah, we have T and R. So I'm guessing T is a transmitter, R is a receiver. So we use this to measure the distance or how far we are away from something. So if anyone here has ever been in a car, your parents' car, and when they're reversing, it makes that beeping sound, beep, 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 beep. This is the kind of device that's in there. So this is just sonar. So it pulses out sound. And because this is a receiver, the sound will come back and it will pick it up. And it will, the time it takes from one pulse to one receiver, we can work out. Because we know the speed of sound, which I don't remember right now, so please don't kill me. The speed of sound we can work out, and that's how we detect how far we are away from something, because it will take a specified amount of time to get there and get back. Here I have 3 random LEDs. I've got yellow, red, blue. Nothing special about these. You can buy a pack of LEDs on eBay for about £1 or £2 again. And in some cases you get resistors with them. And speaking about resistors, so those LEDs, the average LED voltage is about 2 volts, right? So from that, again, I'm going to show you guys how to work out what resistor is needed based on the power supply. So it's typically going to be voltage drop. So we work out the original voltage. Let's say in this case for the Raspberry Pi is going to be 3.3 volts, I believe. The LED itself, they're going to be about 2 volts. So 3.3 minus 2, that's going to give us 1.3. And from there, we can use Ohm's law to work out the actual resistor needed. So this is, again, just a pack of resistors. And as you can see here, I've got 220. So I'm assuming, making the assumption, this is 220 ohms. My eyes are not good enough to read the colors on here. So there is a chart that we should use to read the colors of the resistors, but I'm really lazy. And in the lab I work in, I just go and pick some up from the tray it's in, because I cannot read anything on here whatsoever. My eyes are that bad. Next, we have a 7-segment display. So anyone here that's ever had a digital clock in the past, this is what's used inside of those clocks. We have 7-segment display because this actually has 7 segments, and from that we can make up alphanumeric characters, right? Mainly numbers, because 0 to 9 is what we need for a clock. So that's what that looks like. I'm gonna plug this onto a breadboard. Oh, that's damaged. Well, not damaged, but bent. So some of these are going to be common anode or common cathode. I'll explain what that means when it's time to use it. What else do we have? I don't remember the name of this switch. This is a switch, but I don't remember the name of it, so excuse me. So I've got 3 of them here. There we go. And what else do we have? What's this? I believe this is a sound sensor. So that's obviously the microphone there, and I need to connect this as well. Sound sensor. Again, I don't know the exact name of these things. They come in a bundle, so you can buy these things in a bundle on eBay, Amazon, any one of these electronic stores. I believe we have here a potentiometer, if I'm not mistaken. A potentiometer is simply a variable resistor, meaning this resistor comes in at a specific value and I can change that value. So anyone here that has, so those light switches that you have in your house where you can dim the light and increase the light, this is the thing that's used in some of them, right? Not this specific value, but something similar. Next, we have a motor. Now, motors are kind of tricky. They need quite a bit of power to run them. So typically speaking, we're going to have a motor driver. I thought I had a motor driver chip, but I have no idea where that chip's gone. So what's going to happen, I'm going to plug my motor driver into the Raspberry Pi, have the signal go to the motor driver, and then the motor driver is actually the thing that's going to power this. That's typically how it works. Here I have, this one is a buzzer, not a speaker, but a buzzer. So it has a very limited range of tones, but it's good for very simple applications. So if someone is allowed to get in, it could be beep. If someone is not allowed, it could be beep, 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 right? Very simple range of sound. What do I have next? I think that's everything. In here, I just have 2 more Raspberry Pi Picos, just because I think I've already programmed that one. So for me to do the tutorial for the next section, I need to grab a fresh one to drag the firmware on there to show you guys what to do next. So thank you guys for watching. Hopefully this was, I don't know, enjoyable to someone. This is the kind of stuff I do genuinely like doing. embedded systems is my thing. I really love embedded systems, and the Raspberry Pi Pico has made embedded systems a lot more fun and a lot more. It has lowered the barrier of entry for a lot of people. Reason being, this was not expensive. So this is the Arduino Uno again, not a very expensive device. Again, about 10-ish pounds you can find on eBay. But the whole point is that when looking at embedded systems nowadays, we're looking at IoT, right? Every single application that we use is going to need some form of connectivity, either Bluetooth or Wi-Fi. This particular Raspberry Pi Pico does not come with Wi-Fi or Bluetooth, but the new Raspberry Pi W comes with Wi-Fi. Bluetooth is not activated by default, but I'm guessing at a later date they'll do that. Whereas the Arduino Uno, you would have to buy another board to plug into this to give you Bluetooth and Wi-Fi. For a simple £7, you can get a board that has everything. And another reason I love the Raspberry Pi Pico as well, you can use C++ or C, I believe, but you can also use Python. And for kids or young people learning program for the very first time, I think, this is just my opinion, Python is a lot easier to get into. And it doesn't really matter which language you learn first. Once you learn one of them and you learn the concepts of programming, then programming should be okay moving forward, depending on what you're trying to do. Again, thank you guys for watching. Please like, subscribe, comment, share, and the next video on the Pi Pico should be me showing you the steps of how to set up the Raspberry Pi.